So first, I think everybody did this. I walked around and saw that everybody did this. Like, now you're getting it. Okay, now I have a formula. Let me look at it. So I got these two things, and I'm going to add them up, and I get, this is a little bit nicer than the other ones because they have a common denominator. But then this is also from experience, I looked at the top and I said, wait a minute. These two sets, this side and this side, will partition up the sample space. And some of you drew Venn diagrams so you could see that this A intersect B inside the probability and not A intersect B inside the probability, those two sets partition the space, the sample space. So here's A intersect B, that's the inside of the left stuff. I'm distinguishing between the probability and the sets, right? I'm looking at just the sets right now. And this is not A intersect B, that's that set. Well, the union of these two things equal B, right? And these two sets are disjoint.
Does that mean disjoint?
It means that they have no overlap, right? So I can see that from the picture. This set and this set have no intersection. They're different. So there's a axiom from probability that says if they're disjoint sets and they have a union in between, I'm allowed to separate them by a plus sign. Axiom 3 of definition of probability allows me to take the probability of this side and split them. So that tells me that the numerator is just probability of B. It's kind of a proof. It's not. If you were in a measure theory class, you'd get a lot of points off. But it'll do for us. It'll do. There's a little bit of hand waving going on there. Thoughts? So here I'm being careful. I was just talking to Major Police today in my office, and I was telling him about how you can tell people's personalities from how they do things in the office. My books are all over. They're not in any organized place in the shelves. I've got stuff in the back behind my desk. Even my desk looks a little cluttered. And so I've got a little bit of messiness going on there. But not here. I know I'm living in the world of sets, and I work with Venn diagrams. And then I know that when I go to probabilities, I'm working with numbers. And so whenever I go from the sets to the numbers, I'm very careful about making that switch. I just wish that would transfer to other parts of my life, and somehow it hasn't. So it's unfortunate. Is this clear what happened here?
Like at the end, I get that they're disjoint.
Well, what I want to do is right here, this union. If I go up here, these two things look the same. They're just separated. That one has a plus sign and this one has a union. Okay. So when am I allowed to stack a probability and split them off? When these two sets don't have any overlap. That's axiom 3 of probability.
And then, so what's going on over here?
I'm allowed to split this off because there's no overlap. That's axiom 3 of the definition of probability. So this entire numerator turns out to just be probability. So there was some thought process going on behind this. I had to draw the sets, I had to draw the Venn diagrams, I had to see that, oh, they're disjoint. Then I had to know this axiom 3 off the definition. And anything that I know off the top of my head, that means I've used it. That means that's probably something you should know off the top of your head.
So can't you just look at the circle B and say that because that circle B is completely filled, that it would equal 1?
No. The only thing that's totally equal to 1 that I know of is the entire sample space. I don't know that the probability of B is equal to 1 automatically. And I think that's also on your definition of probability, that the probability of the whole sample space is equal to 1. Okay, anything else?
So you just have to find the axiom or definition that proves what we see is true on the image. Does that make sense?
Yes. So
we say we can see that there's the numerator equally p. So just find the axiom that shows us that that's going to be true.
That's true. That's correct. So there's two ways of doing this. I've met colleagues that read everything first, kind of have everything memorized, and then do the problems. And I was more the type that would start with the problems and go backwards. And the more I hit that definition, then it starts to be memorized. At the end of the day, both of us ended up passing the comps or whatever we had to do. So I'm not saying one method is better than the other. If you're someone that likes to go through and memorize all those definitions first, if you're good at memorization, I say take that path. I've seen people be very successful doing it. The way I've done it is always do the problem and go exactly that backward calculation method. It does end up going at the same place, and I don't think it's any difference in time. I just feel like I'm more productive that way, and I bet the other person thinks they're more productive the other way.
So I got this problem like 2 minutes ago, but now I'm like confused. So, like the way I'm looking at it on the pictures, it's that when you add.
When you union this side and that side, you don't add sets, you union them.
Okay.
They ended up being just B.
Yeah.
Right?
Yeah, just be.
So now, like he said, I went, what allows me to do that? Because this is not union of two sets, this is probability of the split of these two things.
Okay.
So what allows me to leap from the union to the plus sign between the probabilities? Axiom 3 of probability. So one method to do that is to memorize the definition of probability, and you go, oh, yes, I'm supposed to do that. Then the effort's front-loaded. You're memorizing it before you start. The other way is to say, okay, I need to go from here to here. I'm not allowed to leap from here to here. Let me dig around in the book until I can find something that allows me to leap from the union of sets to the plus sign of probability. And the key thing in all that is I was not confused that these were sets, and I knew that these two things were different.
Right.
That's the organization part of it. Okay, got it?